All right. Hey, so this is intended to be a linear equations crash course. So what is a linear equation? Well, a linear equation is any equation that, at least kind of informally, um, visually, geometrically, it's any equation that when you graph it, it's just a straight line. So here's one. Here's what another one might look like. Both of these are linear equations. Maybe a little bit more mathematically rigorous of a definition of a linear equation is any kind of equation that has a constant slope. The slope anywhere, like anywhere on this equation, or on the graph, it's always the exact same slope. What do I mean by slope? It's kind of like the angle of elevation or the angle of depression of the line of the equation when you've graphed it. So on the left, this is an example of a linear equation with positive slope. On the right is an example of negative slope. So you can kind of think of it like, as far as the slope goes, just sort of looking at the graph and determining whether it's a positive or a negative slope. Sort of read the graph from left to right, or look at the graph from left to right. And as you move from left to right, is the equation increasing or is the equation decreasing? Like it's very, it is just that intuitive, the way that we're using slope. So yeah, left to right, this equation is constantly increasing. It's got a positive slope. Left to right, this equation is constantly decreasing. It has a negative slope. Right. So if slope is kind of the defining characteristic of a linear equation, it would make a lot of sense that we should have some kind of formula to derive the slope of an equation. And to derive the slope of an equation, you're going to need 2 points, 2 distinct points that lie on the graph. So suppose we have our linear equation. Looks like this. And we want to choose 2 different points that are on this graph. I'll choose one down here in the lower left. That's going to be the arbitrary point x1 comma y1. And then sort of further up here, x2 comma y2. It doesn't matter which 2 points you choose, as long as they're 2 different points. So slope between 2 different points is given by, and I'm just going to kind of like say this, I'll state this, I'll just sort of state this and then I'll show how it sort of relates to like the graph, the geometry of the graph. So slope between the 2 points, x1, y1, and x2, y2, regardless of positive slope, negative slope, whatever. The slope between these 2 points, or the slope of this equation, is y2 minus y1 over x2 minus x1. So this is like the formula. Sort of informally, the way that we often talk about slope is we call it rise over run. Meaning slope is really just like a ratio. Like if you take 2 different points on a linear equation, slope is the ratio of the difference between the vertical difference between the 2 points divided by the horizontal distance of the 2 points. So it's really just like a ratio. And this equation can kind of be seen if you look at like the graph. We can kind of make this right triangle here because so that's not a very straight line. You have to imagine that this on the bottom is a straight line. So this would be right here, the point x2. Up here is y2. Over here is x1, and then down here is y1. So what we're looking at, this y2 minus y1, is the difference between it's the vertical difference between these 2 points. Like right here, this line has a length of y2 minus y1. And then the horizontal distance is a difference of the x values, x2 minus x1. So we're just saying, what is this ratio of the difference of the vertical translation divided by the horizontal translation? That's what this slope is saying, sort of geometrically, I guess. So suppose, just as an example, if a line goes through the points, what does it go through? I have 6, 4, and -1, -2, which somewhat corresponds to these 2 points, actually. That's just sort of coincidence. But in any case, so a line through these 2 points has a slope of m, which equals, and it may help you, just to kind of keep things straight, it may help for you to label these coordinates, x1 comma y1 and x2 comma y2, the subscripts, these little ones or little twos beside them, they kind of designate like the coordinate pairs, so they should match up. X1, Y1, X2, Y2, and it's arbitrary. You can label it the other way as well, X1, Y1, X2, Y2, but you just need to keep it straight. So slope between these 2 points is given by, one way of calculating it would be -2 minus 4, so the difference between the y's, divided by -1 minus 6. So -2 minus 4 is -6. -1 minus 6 is -7. So negative divided by negative is positive. So the slope is 6/7. Notice that, like I said, it's somewhat arbitrary what you choose to be your x1, y1 or x2, y2. If I had done it the other way, where I first chose this to be my x2, y2, then the slope would still be 4 minus -2 divided by 6 minus -1. Oops. But doing this, subtracting a negative, 4 minus -2, this is really the same as 4 plus 2. So 4 plus 2 is 6. Same thing down here. 6 minus -1 is 6 plus 1 is 7. So you get the same thing either way. But here is a problem, and I'm going to label this as bad math. So if you're taking notes or anything, just know that I'm about to show you what is the wrong thing to do. It's always helpful to see what the right thing is to do. It makes it even clearer if you see what the wrong thing is to do. If I said the slope is -2 minus 4 over 6 minus -1, then -2 minus -4 is -6. 6 minus -1 is 6 plus 1 is 7. And this comes out as -6/7. So what did I do wrong is I kind of mixed up my subscripts, so to speak. I chose first my y2 as this -2, which means that -1 should be my x2, should be right here. So one way to kind of double check that you're doing this correctly is that when you write everything out like this, you should be able to look at the numbers that are in each column, and they should represent one of the coordinate pairs. So right here in this column, I have -1 and -2. Here's the coordinate pair. Same thing over here. I have 6 and 4, coordinate pair. Exact same thing down here. 4 is over 6 because that's the coordinate pair. -2 is over -1. That's a coordinate pair. What happened down here, -2, 6, that is not one of the coordinate pairs that I have. So you do have to be careful in that regard. As long as you keep your subscripts consistent, then you'll get the right slope. Okay? So there is that. Right, so a couple of things, I need more paper. A couple of other things that we'll talk about now is, all right, we just figured out how to find slope. Now let's talk about what the equations of a linear equation look like. So there are 3 forms. Of linear equations. The first one that I'll talk about is my favorite because I find it to be the most accessible. Looks like it's not focused. And it's also, I think, the one that, for most of us, it sort of gets drilled into our head whenever you take this course. And that form is called slope-intercept form, which in its general form is y equals mx plus b. Why do we call it slope-intercept form? Well, because the key characteristics are m, which is the slope, and b, which is the y-intercept. So yeah, slope-intercept form. What is the y-intercept? This is where the graph crosses the y-axis. Okay? All right. So if we want to write out an equation that is in slope-intercept form, we need two pieces. We need both the slope and we also need the y-intercept. So I guess let's just let's take this last problem that I was working with, where we have these two different points. So just to remind myself, the points are 6, 4, and -1, -2. And we want to write this out in, maybe we want to write this out in slope-intercept. Well, we've already found the slope. We just did that. The slope is 6/7, 6/7. But the y-intercept, b, we need that too. How do we find b? Well, in this case, one way of finding b, which I think is the simplest way of finding b, is that we take either one of these points and we plug them in for y and x in our equation, which leaves only b as the variable. So let's see, I'll choose 6, 4. You can choose either one. You're going to get the exact same answer for b. I'll choose 6, 4. So remember, the way that these are listed out is x comma y. So it's alphabetical order. First x, then y. So if I want to write this, I'm going to substitute everything into y equals mx plus b. Okay, y is 4. So 4 equals m, which is 6/7, times x, which is 6. I just chose these numbers, the coordinates just kind of randomly, by the way, so it's already looking like this is going to turn into not the prettiest y-intercept. So, and then we just solve for b, because now b is the only variable in this equation. We can just solve for b. So we'll do that. 4 is equal to 36/7 plus b, so b is equal to 4 minus 36/7. 4 times 7 is 28, so 4 is the same as 28/7 minus 36/7. And now that I have a common denominator, I can just do the arithmetic in the numerator. 28 minus 36 is what, -8? -8/7. So b is -8/7. So what is the equation of this line? It's y equals 6/7 x minus 8/7. It's probably most commonly how you would write this. Just kind of as a side note, you could also write it as y equals 6x minus 8/7. Maybe not quite as standard, but these are equivalent. They're the same thing. Me personally, I would write it this way because it makes it really obvious. What's the slope? What's the y-intercept? So then, and the reason that I really like slope-intercept form is because it makes it very easy to graph. So let's do that. Let's see here. I have to be a little bit careful. This is not going to be the best example since these are not nice, clean numbers. We'll do it anyways. I'll do the example. Maybe I'll come up with another example after this that's a little bit cleaner and easier to see. So -8/7, that's -1 1/7. Let's see, I'll go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So negative 8/7, that's negative 1 and 1/7, so it's just below this negative 1. My graph is not even large enough for the precision. But now that I have this, I use my slope, which is rise over run, to find a new point. So it rises by 6 units, so 1, 2, 3, 4, 5, 6, and then it runs 7 units. 1, 2, 3, 4, 5, 6, 7. So about right here, yeah? So here's what the equation roughly looks like. Now that I think about it, I don't think that I need to do a simpler example. I think that that's pretty decent. This is our equation. Y equals 6/7 x minus 8/7. Okay. All right, so that's the first form of a linear equation. Let's see, did I use the back of this? No, I haven't yet. The second form of a linear equation is, which I think is also maybe like the second most common form, is called point slope form. And what does that look like generically? It looks like this. Y minus y1 equals mx minus x1. So this is where it has a slope of m, and it passes through the point x1 comma y1. So if you're given an equation, or you're given a problem and it says, oh, an equation has this slope and it goes through this point, then you can just immediately write the equation in point slope form, which is kind of the upside of it. It's really easy to write point slope form, but for me, and I mean it is still just as easy to graph it. It's technically just as easy as y equals mx plus b, but just for whatever reason it feels slightly more complicated. So let's suppose that we have an equation with slope 1/2, and it goes through the point -2 comma 1. And we want to write out the equation in point slope form for this graph. Well, it's just plugging things in. So y minus, and notice that this is the way that this is generically written. It's through the points x1, y1. So this point, -2, 1, this is my x1, y1. So I fill this in for x1, this in for y1. Y and x just stay as y and x. So y minus 1 equals 1/2 x. Let's see, it would be x minus -2, but x minus -2 is +2. So that's the equation. And just a really quick sketch, it's exactly what we just did with point slope form. We know that this thing goes through the point -2, 1. So here's -2 comma 1. It has a slope of 1/2, meaning it rises 1, it runs 2. So rise 1, move up 1 unit, move right 2 units. Right here. This is our graph of y minus 1 equals 1/2 x plus 2. All right. And suppose, though, that we, were given all of this. We were given the slope, we were given a point, but we were asked to write the equation in slope-intercept form, not in point-slope form, which is how we have it. But what if we were asked to write it in slope-intercept form? Well, at least in this case, because of the numbers that I chose and the way that I just graphed it, we actually just found the y-intercept. So we could just write it already. It's going to be y equals 1/2 x plus 2. But suppose that it didn't come out so cleanly on the graph, and we just had this equation and we wanted to rewrite it in slope-intercept. How do we do that? Well, we just solve for y, because that's really all that slope-intercept form is. It's just solving for y. Where did I write it? Oh, it's on the other side of this page. Right. So y equals mx plus b. Solved for y. So if we want to translate this from point-slope form into slope-intercept form, we'll just solve for y. How do we do that? Well, first we'll add 1 on each side. And I guess it's a little bit more than solving for y, because it specifically needs to be of the form y equals mx plus b. And if I just add 1 to each side, then I technically have solved for y, but it's in this form, 1/2 times x plus 2 plus 1. So I've solved for y, but this is still not in slope-intercept form. I need to sort of simplify the right-hand side, and then it's in slope-intercept form. So how do I do that? Well, first I have to distribute the 1/2. So this becomes 1/2 x plus 1/2 times 2 is 1. And then there's this other plus 1 here. And simplifying, y equals 1/2 x plus 2. So that's the equation, y equals 1/2 x plus 2. These are the exact same equation, just written in 2 different forms. All right, and then the very last form that is maybe the least common, it comes up sort of, in my opinion, you see it the least. Somehow, for some reason, I consider this to be almost like, for whatever reason, I get this sense impression writing it in this last form, which is called standard form. It's kind of like taking a linear equation and like dressing it up in like a tuxedo or like a ball gown or something. I don't know why. That's the sense impression that I get. It somehow feels more formal. Standard form does. And standard form of a linear equation is this: ax plus by equals c. Specifically, it's written this way with the capital A, B, and C. Why are A, B, and C capital? Well, because the way proper standard form means that A, B, and C are integers, where A, B, C are integers. What's an integer? Well, an integer is any whole number, positive or negative. That's an integer, as long as it is a whole number. So, in standard form, A, B, and C must specifically be integers. Right, so how would we go from, and if you were given, by the way, I'll just kind of say this rather than going through the example, because we kind of already did it. If you were given an equation in standard form and you were asked to write it in slope-intercept form, it's the same idea. You solve for y. If you were asked to write it in point-slope form, what I would do is I would first write it in slope-intercept form, because that will give you the slope. And then if you had to write it in, maybe like, this would be a strange question, but I can see it coming up. If you were asked to write it in point-slope form, but not using the y-intercept as the point, solve it for y to get the slope, plug in any x value and solve for y. That gives you a coordinate pair, and then write it in point-slope form. But maybe what might be a little bit more common is if you're given an equation in either point-slope form or slope-intercept form and asked to write it in standard form. So if it's in point-slope form, what I would do first is, again, solve it for slope-intercept form. Then from slope-intercept form, all that we have to do, well, the first thing that we have to do, like this one, y equals 1/2 x plus 2, First, I have to get rid of the fractions. Everything has to be an integer. A, B, and C, all of the coefficients, they have to be integers. So right now, the only non-integer in this is this 1/2. How do I get rid of this? Well, I can multiply it by really anything that I would like that will cause it to no longer be a fraction, which in this case is really any even integer. So 2, 4, 6, 8, 10, any one you want. They will all give you standard form, or put everything into the form so that you could solve it for standard form. The easiest one is 2. If I multiply 1/2 by 2, then this just becomes 1. But note that if I am multiplying this 1/2 by 2, I have to multiply everything by 2. That's the way that equations work. If you're doing something to one piece of the equation, in particular multiplying, so adding and subtracting, actually, yeah, adding and subtracting is still on the table as long as you just add the same thing to both sides. When it comes to multiplying, you have to multiply both sides by the same thing. So whatever you do to one side, you've got to do to the other. So I'm just going to multiply this whole thing by 2. So this 2 gets distributed to everything. 2 times y is 2y. 2 times 1/2 is 1, so that just becomes x. 2 times 2 is 4. So that's kind of step 1. I no longer have any non-integers in here. The last thing is that the x and the y have to be on the same side of the equation, and the standalone constant needs to be on the other side of the equation. So my standalone constant is 4. I need to move x over to the right. So I guess there's actually kind of two ways of writing this. Maybe it would be more common to move 4 over to the left and 2y over. I'll do both. If I subtract x from both sides here, then I would have something like 2y minus x equals 4. Or I could go the other way. I could subtract 2y over here, 2y from both sides, and I could subtract 4 from both sides, in which case I would have x minus 2y equals -4. Right? Yeah. Yep. So both of these are kind of fine. I'd say maybe this second one might be the preferable way of writing it, but as far as I know, both of them will be acceptable in standard form. Okie dokie. So that is your crash course on the 3 different types of linear equations. If you've got any specific questions, let me know. I'll be happy to make a recording or try to answer them in the comments or wherever I see you.